Okay, last module. It's about sorting algorithms. So basic terminologies. So internal sorting. What do you mean by internal sorting? Any idea? Sorting is performed in a computer's internal storage. So this type of sorting is known as internal sorting. If sorting is performed in computer's internal storage, then it is known as internal sorting. Sorting a small set of data is known as internal sorting. Then another type of sorting is known as external sorting. External sorting means it will be handling massive amounts of data. Actually, this type of sorting, internal sorting, means we are using a small set of data. Here we are using massive amount of data. So when data being sorted do not fit into the main memory, that means it is a bulk amount of data is there, massive amount of data is there. So it will not be fit in the main memory. So here the sorting means in this case internal sorting, we are using small set of data. So computer's internal storage is enough. Here we are having massive amount of data. So this data cannot be fit into the main memory. So this is the main difference between internal sorting and external sorting. So we are going to study internal sorting. An internal sort is any data sorting process that takes place entirely within the main memory of a computer. So whenever data to be sorted is small enough to be held in main memory, so in this case, the data set must be small. If it is small, it can be stored in the main memory. For sorting large data set, it may be necessary to hold only a chunk of data in memory at a time, since it all fit. So if we are having large data set, then we have to divide the whole data set into chunks. Chunks means, what do you mean by chunk? Into some pieces. For example, if we are having some 10,000 data, then we can divide chunks like size of the chunk may be, suppose there are 10,000 data, then size of the chunk may be some 1,000, so that we can move 1,000 data into the main memory and we can sort it. After that, you can remove that data from the main memory and you are able to load the next 1,000, that is next. So totally there will be 2,000, like that. You can after that you can load the next chunk, that is 2,000 to 3,000, like that it will be continued. Any reading or writing of data to and from this slower media can slow this sorting process. Some common internal sorting algorithms include bubble sort. Did you study bubble sort in the smaller classes? Yes, tell me. Hello.
Oh,
You know.
C programming പഠിച്ചിട്ടുണ്ട്.
Okay. Bubble sorting. Then insertion sort, quick sort, heap sort, selection sort. We have to study these type of sortings in this chapter. Next is external sorting. We already studied that. External sorting means it is applied to a large set of data that is handling massive amount of data. So in this type of sorting, uh, we need to do the sorting in external memory. So actually the data do not fix in the main memory. So what do you mean by main memory? Main memory means usually it will be RAM. Instead, they must reside in the slower external memory that is usually a hard drive. External sorting typically uses a hybrid sort merge strategy. In the sorting phase, chunks of data small enough to fit in main memory are read, sorted, and written out to a temporary file. We had already seen one example. If you are having, it's just an example. Actually, it is a small number. Suppose we are having 10,000 numbers. We can move the first 1,000 to the main memory and do the sorting. And after that, you can store it in a temporary file. Then you can move the next chunk, that is data from 1,000 to 2,000. After that, you can move the next chunk, that is 2,000 to 3,000. Move it to the main memory, then sort it. Then after that, you can store it in a temporary file. In the merge phase, so we are having so many subfiles. So here we are, how many chunks will be there? We are having 10,000 data. How many chunks will be there? Chunk size is 1,000. How many chunks will be there?
10.
10.
10.
So there will be 10 subfiles also. There will be 10 sorted subfiles. After that, in the merge phase, we have to combine all the sorted files. So after sorting, there will be a single file, and that file will be large. That means final file will contain how many elements? This large file will contain how many elements?
10.
Tell me. Yes? Louder, please. How many elements in this single file? Actually, first chunk contain 1,000, second chunk contain 1,000, third chunk contain 1,000. Like that, we have how many chunks?
10.
10 chunks. So after merging means we are going to so this is one sorted file. This is next sorted file. Like that, we have 10 sorted files. In each file, we are having 1,000 elements. So finally, we are in the merging phase. We will merge this 1,000 and this 1,000 and this 1,000. All thousands are merged into a single file. So that means in this file, how many elements will be there?
10,000.
Yes, 10,000. Okay, for example, external merge sort. So example for this sorting is external merge sort. Another example is bucket sort. So it is simplest sorting method, that is bubble sort. You have to compare each element with its compare each element with its neighbor to the right. So we are comparing the first element and second element. Then in the next step, we are comparing second element and third element. If they are out of order, then we can swap them. Otherwise, no need to swap it. This puts the larger element after swapping. The larger element will be at the very end. The last element is now in the correct and final place. So compare each element except the last element with the neighbor to the right. So if they are out of order, swap them. This puts the second largest element in the next to last. So this last two elements are now in their correct and final places. So next we are going to compare each. Okay, I will explain the sorting first. Okay, these are our elements 7, 2, 8, 5, 4. These are our elements. So it is stored in an array. Then, so we have to swap the first two elements. Which are the first two elements?
7, 2.
Tell. Ah, 7 and 2. These are the first two elements. First, we have to compare these two elements. Just compare 7 and 2. 7 and 2. After comparing, what we have to do?
Swap.
Swap when? When? So just like this. Logic is very simple. You can compare. You can compare A of 1 and A of 1 and A of 2. So compare just A of 1 and A of 2. So here A of 1 is 7 and A of 2 is 2. Okay, what is the next step? Tell me what is the next step? If it is not in order, if it is not in order, then you have to swap it. Swapping means you have to exchange this 7 and 2. So is it in correct order? Actually, we have to store the elements in ascending order. So 7 and 2. Is it in ascending order?
Alla.
Tell me. No. So we have to swap it. So we have to exchange it. Exchanging it means we have to store like this. 2, comma 7. Okay. So first we are comparing first two elements. If it is not in the order, then we have to swap it. This is the step. First we are comparing first two elements. Then if it is not in the order, then we have to swap. So here we can see that this 7 and 2 are not in order. So we swapped it. That's all. What is the next step? Tell me. Tell me. Hello. Amina. So again,
അടുത്ത
so
compare
first we
ചെയ്യും.
are comparing A1 and A2. Next we have to compare. Next we have to compare A2 and A3. After that we have to compare A3, A4, 3 and A4. Like that we have to continue up to the n numbers. Okay. So what is the next step? Next step, tell me.
8 to 8 3 compare ചെയ്യും.
So up to this, okay. 2 is in the right order. Then we have to compare this 7 and 8. That is, we have to compare A2 and A3. Is it in same order? First step comparing. Second step, we have to check whether it is in the same order. Is it in same order? Same order means is it in ascending order? That is a question.
Oh.
Tell me. Yes, it is in the same order. It is not in the out of order. So it is in the ascending order. So no need to exchange it. That is very important. If it is out of order, then we have to exchange it. If it is in the same order, then no need to perform any operation. Okay. So up to this we had compared A1, A2, and then A2, A3. Then what is the next step? We have to compare. So we just write this 7 and 8. Look at this example. We had just written this 7 and 8. There is no exchange. Next we have to compare. So we had compared A1, A2. Then in the next step we had compared A2, A3. Then in the next step we have to compare A3 and A4. Okay, A3 and A4 means we have to compare this 8 and 5. Is it in the correct order?
അല്ല.
So we have to
Swap.
swap it. So 5 and 8. So 5 comes in the third position and 8 comes in the fourth position. Then what is the next step? Tell me. We have to compare A4 and A5. So 5 and again 8 and so next step in the next step 8 and 4 are compared. Is it in correct order?
അല്ല.
No. So we have to exchange it. So 4 and 8 like that. So now this step means all the elements are in the correct order. That is 2, 7, 5, 4, 8. So
Correct
any
order.
doubts? If you have any doubts, you can ask.